Alrighty, should be all good to go. Good morning, AP Computer Science A. Oh, that's not the screen I want. Good morning, AP Computer Science A. This is Tuesday, May 5th. Happy Cinco de Mayo. Happy Revenge of the 5th. I was not able to see you on Star Wars Day. I still do have my Star Wars attire on, though, to celebrate the occasion. I don't have any Cinco de Mayo colors or anything like that. Otherwise, I definitely would have worn some attire for that. But still, enjoy the day anyway. Happy day after Andrew's birthday as well. Very important to remember that occasion. Today, what I'd like to do with you is I would like to go through more of the free response question practice with you. I want to go over the progress assessment that was due on Sunday night just to make sure you understand that. It was very similar. It was a very similar problem to the one that we went through in class with the mechanical arm that went around and selected solutions from an assembly line. Very, very similar to that. This one is a robot that picks up toys, apparently, from a hallway. I didn't make up the scenario, but hey, you know, maybe it's the way of the future. So I'd like to go over that with you. And then after that, I have another free response question that I prepared for you. It's another question just like the one we went through last class, where the College Board was like, we strongly recommend that you go over this problem with your students. So I was like, all right, well, you don't have to say that twice. So I'm definitely going to go over that with you. It's more on methods and control structures rather than on arrays. So it'll be a nice little change of pace for us today. So that's really the plan of attack. I also have the scoring guide for that as well. So I want to talk about a lot of how you can earn a lot of partial credit on types of questions like that. Okay, so that's really our agenda for today. What I do want to tell you, though, is that we do have 10 days until the AP Computer Science A exam. Oh, boy. That deadline sneaks up fast. It's on May 15th. Okay? Hopefully, you were studying, and hopefully, you're taking it seriously. The AP exam, if you've never taken an AP exam before, mark my words, the AP exam, at least for a STEM class, I'm not as familiar with, like, AP US History or AP Hug or anything like that, AP Psych. Not super familiar with those, but at least for the science and math and technology ones, it is definitely something that you should be studying for, probably starting today at least, going until the date of the exam, a little bit every day, all right? It is not the type of test that you can kind of just study for the night before. It is absolutely not that. We want to make sure that we're really pacing out our studying and really doing the best we can to do the best job that we can. I want to reiterate to you all the resources that you have available to you. I set you up on CodeHS, which is normally a site that you have to pay for, but due to the current circumstances, it is being offered for free. So I highly recommend you take advantage of that. It's a very Khan Academy-esque type of application where it can walk you through and provide a lot of great examples on the concepts that we'll be focusing on the AP exam. So I really highly recommend you visit that. The textbook is posted on Classroom, so I highly recommend that you take a look at that and read over that. It's all there. It's available for you. There's a ton of practice problems embedded within that textbook, like practice questions and answers and all that great stuff, and explanations of the answers, so I highly recommend looking at that. I want to remind you again that the College Board is providing free video review of AP Computer Science A topics, which is going to be, what was I going to say? Oh, which is available on their YouTube channel. I know I've linked that in the past. I'll make sure to post it on Classroom and make that available for you if it is not. But you should just be able to search in YouTube AP Computer Science A College Board. It's probably the first result that pops up. So you can go ahead and watch their video lectures as well. And if you want to meet with me to go over any other practice problems or questions and answers, please, please, please feel free to do that. All right? Please feel free to do that. Now, one thing that I have done historically for my AP Computer Science A class is the day of the AP Computer Science A exam, I have provided a little extra, just a little token of my appreciation for your hard work and determination to just lift you in some positive spirits and make you feel happy for the AP exam. That being, I've given you lunch. So with the current circumstances of it being difficult to get out and about, I'm still thinking about how I can do that for you. I do still want to do that for you on the AP Computer Science, day of the AP Computer Science A exam, which is, again, Friday, May 15th. But I'm not quite sure how that's going to work out, but I will get back to you at the end of next class. Okay, that's Friday. So that'll give us a week to make sure you clear your calendar to make sure you can come on by for some lunch. All right. I have always done that for my AP class, so I don't intend on the current circumstances getting in the way of that. Of course, we'll be safe and we'll be healthy and we'll be contact free and all that stuff, but we'll figure out a way that we can make that happen. All right. I don't want you to skip out on that experience. So that's an exciting thing that should be coming your way very soon. But anyway, does anybody have any questions or comments or concerns before we jump into the free response stuff? Again, another reminder about your final project as well, which is due at the end of the month. Okay, the last thing I want to mention before we officially jump in is the fact that typically in AP Computer Science A, after the AP exam, what I do is I allow you to select a topic as a class and say, hey, Mr. Georgia, I'm really interested in learning about this. It has to be computer science related. It cannot be any video game nonsense or whatever that the kids are doing these days. But it has to be, like in the past, we've done AI, we've done graphics, we've done stuff like that. So that, unfortunately, I'm not going to be able to accommodate that for you this year because of all the distance learning and the added pressures that exist. However, what I do plan on doing is I do plan on revisiting the topics that we've yet to get to on the AP Computer Science in AP Computer Science A. That will be just kind of finishing off inheritance as well as talking about searching and sorting algorithms. The reason why I want to do that is because I feel like it would be a disservice of me not to. If you get through this class, it is assumed that you have covered that stuff, and going into college, it will be expected that you know, or at least it'll be very beneficial if you have a background on all of that information. So I will do that for you after the AP Computer Science A exam. I'll probably spend one day revisiting and refreshing on inheritance, and then another maybe 2 classes talking about how you searching algorithms and sorting algorithms, as well as something called Big N notation. Big O notation, not Big N, jeepers. Big O notation. So we'll talk about that as well. All right. So without the risk of just blabbering on for a half hour, let's actually get into how these free response questions are done. So go to the answers. So I will post this on Classroom right after this class, but these are the solutions for the free response question that I assigned for you for a progress assessment. I want to remind you that with any solutions that I post, it is, of course, just one way that you can tackle a problem like that. It is not the only solution that I'm accepting. As long as your code does something equivalent in functionality to what I provided, then it can get full credit. So the way that this program works is it's a little robot that goes through a hallway and picks up toys and other objects. The hallway is bounded by 2 walls. You have a left wall and you have a right wall. Essentially what happens is the robot wants to move throughout the hallway. If there's something on the current space, it wants to pick that up. If there's not something on the space, it wants to progress forward to the next space, if it can. If it can't, because it's at the end or the beginning of the hallway and blocked by a wall, then it has to turn around. All right, so that's pretty much what we're looking at here. The first method that you had to write was a method called forward moved blocked. Method forward moved blocked returns true if the robot has a wall immediately in front of it, so it cannot move forward. So it returns true if it's blocked, otherwise it returns false. Look at how the robot can be blocked. In our little examples up here, you could see, well, how is the robot blocked? It's either going to be blocked if it's at the end of the hallway and facing right, meaning you're trying to go right, but you're at the end, you hit a wall, or it's at the beginning of the hallway and facing left. So that's kind of how you have to understand that. You have to understand, oh, there's 2 ways that you can really be blocked here, if you're at the end and going right, or if you're at the beginning and going left. So that really constituted the structure of this method. It's a very short method, but it's just saying if you're facing right and you're at the end of the hall, or you're facing left, meaning that facing right is false, and you're at the beginning of the hall, then that's true. Then you are blocked, right? You can't go forward. If you're not either of those things, though, then you would return false, because that means you can progress forward. So it's just a matter of looking at your scenario and saying, if we're facing right and we're at the end, or we're facing left and we're at the beginning, then we are in fact blocked, so that's why we return true. Otherwise, we return false. Question about that at all? The second part was called move. It was a method called move. I love, love, love personally when the AP Computer Science A exam gives you problems like these, because it literally, like with an algorithm that's associated with it, because it quite literally tells you what you need your program to do. And the way that I structure the logic of the method that I wrote is exactly in line with what this should do. So the move method does the following. It says if there are any items on the current tile, one is removed. So when I went to write my method, I said, well, what does my move method have to do? It first has to say, if there's an item on the current tile, remove an item. So I started with, if there's something on my tile, if the hallway position that I'm currently situated at, hall at index position, is greater than 0, meaning that there's stuff there, remove an item from the tile. Hall at index position minus minus. Okay, we took one away. Next, it says, if there are more items on your current tile, then the robot remains on the current tile facing the same direction. So that pretty much means that if there's more items on the current tile, we're not going to do anything. We're pretty much going to stop. I didn't actually write that in because what I wrote in was this: if there are no more items on the current tile. So if there are more items, we're just not going to do anything. So really, this is just going to end. It'll do this. This would never happen, and you would just end. But if there are no more items on the current tile, right, what does the robot do? If it can move forward, it advances. Well, how do we know if it can move forward? We have this method we just wrote called move forward blocked. So if it can move forward, if move forward blocked is false and facing right is true, then I move right. We move right by advancing one position. If we're not blocked and we're facing left, then I advance forward by moving backwards one position, right? Subtracting. That's why I had to check to see the facing right and facing... Actually, I'm just realizing I wrote this. Facing left is not a variable. Facing right should be equal to false, not facing left is true. Facing right should be equal to false, because that means we'd be facing left. So that means I'm going to subtract. And otherwise, so if I am not blocked and facing right, not blocked and facing left, the else would therefore be that I'm blocked. And so if I'm blocked, if the robot cannot move forward, it reverses direction and cannot change position. So I just said facing right is the opposite of facing right. It turns around. Hopefully that makes sense how that was done. Just literally breaking down the conditions it tells you. Last but not least, this method called clear hall. It pretty much runs through the whole program of clear hall, and it returns the number of moves that it took. It's just a simple matter of making a little counter and saying while hall is clear is false, because we do have this method, remember, called hall is clear. It's important to actually show all of the, or rather not show, but use all of the tools you're given. We have this method called hall is clear. It doesn't matter how it works. The only thing that matters is that it returns true if the hallway contains no items. So we could write that if you wanted to, but you don't have to in the context of this problem. I would just say while hall is clear is false, meaning there's still stuff there. Let's keep moving, and every time I move, we're going to increase the number of moves. Okay, and that's pretty much it. Question about that at all? Feeling good? Feeling happy? Alrighty, so here's the free response question that I posted for today's class. You can, and I highly recommend that you do, follow along with it on Google Classroom. You can read it on your own. You can go through on your own. I posted it this morning. I posted it kind of right before class, so I do apologize in getting to you a little later than I would have liked. But it does take a long time to type it all out, so I hope you understand. But it is here for you now, along with the scoring guide. So we're going to go through it together right now. So this problem says, a mathematical sequence is an ordered list of numbers. Ooh, little pre-calc, sequences in series. How fun. This question involves a sequence called a Hailstone sequence. I actually didn't know that this existed before reading this question. If n is a value of a term in a sequence, then the following rules are used to find the next term, if one exists. If n is 1, the sequence ends. If n is even, meaning that the actual value of this number is even, then the next term, I divide n by 2. I do n divided by 2. If n is odd, the next term is 3n plus 1. Simple, straightforward rules. For this question, assume that when the rules are applied, the sequence will eventually terminate with the term n equals 1. So there won't be any infinite series, or infinite sequences rather. The following are examples of Hailstone sequences. So we have 5, 16, 8, 4, 2, 1. The way it breaks down is the first term's 5, so you would do 5 times 3 plus 1 to get 16. Then when you have 16, 16 is an even number, so you divide by 2 to get 8, divide by 2 again to get 4, divide by 2 again to get 2, because those are all even numbers. Divide by 2 again to get 1, still an even number. And now since the sixth term is 1, your sequence ends. Per the rules of what's supposed to happen in this thing called a Hailstone sequence. In example number 2 here, it's just the sequence 8, 4, 2, 1. If we start with 8, your sequence would go 4, 2, 1 because it would just be this little subset actually of the sequence above it. Are we happy with that? Hopefully it makes sense, it's clear. Now, we have this thing called the Hailstone class that's shown below. It's used to represent a Hailstone sequence. You'll write 3 methods in the Hailstone class. So the first method we have to do is we have to return the length of a Hailstone sequence that starts with n as described in part A. And the precondition, we don't have to worry about negative numbers. Your precondition is that n is greater than 0. So let's take a look at that first before we actually focus on any of the other methods here. All right. So if I need to return the length of a sequence that starts with n as described in part A, we pretty much need to run through the entire sequence, right? So let's have start with some sort of variable to represent the number of terms that we have. So let's say int number of terms in the sequence, and let's start it out to be 1. The reason why I'm starting the number of terms to be 1, actually we can call it length, but I'll call it num terms. The reason why I'm starting it to be 1 is because if you passed in the only thing that would actually stop the sequence right away is the number 1, it still is something that is of length 1, so you wouldn't ever have something that's length 0, so that's like you wouldn't have a sequence that has no elements in it, so that's why I think it's important to start it at 1. Now I would say while n is not equal to 0, or sorry, not equal to 1. Because 1 is where the sequence ends, right? It says up here, according to the rules, that as long as the sequence is not 1, we're going to do either of these two things. Okay? The next thing says if n is even, then the next term is n divided by 2. Well, how can we make sure if n is even? Well, we can use mod to help us out with that. I can say if n mod 2 is 0. That means if n is even. Remember, mod is the great way to check for even and odd. Then I want to take n and make it equal to itself divided by 2. So I'd say n is equal to itself divided by 2. Okay? If n is not even, then it is therefore odd. We don't have to put an else if, because clearly if you're not an even number, then you are an odd number. And if it's an odd number, we would take n and make it equal to 3 times itself plus 1. Like that. Okay. The last thing we really have to add into here is the fact that the number of terms has increased. And so all I would do here is say number of terms plus plus. You can do that independently in each statement if you so desire. Like you could do it right here and then again right here. But regardless of whether or not this is even or odd, we do have to increase the number of terms. And last but not least, we do have to return, because it says that we need to return an integer, we have to return the number of terms. Okay. And I believe that's it for determining the length of this Hailstone sequence. It literally just goes through the sequence according to the rules that were described up here, and that should keep track of how many terms we've gone through. Again, in the worst case scenario that the user provides the number 1, the number 1 is still a sequence of length 1, so that's why I can't start with 0 terms. We'd have to start with 1 term. Okay? Likewise, I guess what you could do if you really wanted to is you could say instead something like, I'll do it up here. You could instead, I guess, say, it's coming to me now, you could say like if n is 1, then you could say return 1, and then like else, and then run through all this, the rest of this stuff if you really wanted to. That will accomplish the same exact goal, if you so desire. Question about that at all? Okay. Next thing says, Hailstones, this is part B. Part B says we have to return true if the Hailstone sequence that starts with n is a long sequence and false otherwise. So let's see when it's considered long. It says a Hailstone sequence is considered long if its length is greater than its starting value. Ooh. For example, the Hailstone sequence in this example, 5, 16, 8, 4, 2, 1, is considered long because its length 6 is greater than its starting value of 5. Cool. So we have to just determine if a sequence is considered to be long or not. We can do that, no problem. Okay. What I would do is I would say, well, we have this value called n. N is the actual starting value of the sequence. And so I could find out how many steps a sequence actually is for this Hailstone sequence by just doing Hailstone length. That's the method we just wrote for part A. So if I did Hailstone length of n, will that not tell me how long that this sequence actually is? Right? That would tell me exactly that. And so what I can say is I can say if, I don't know where my bolded font went, if Hailstone sequence of length n is greater than n. Right? If that's true, if the number of terms in the sequence, the length, is greater than the starting value, then I can return true. And if that's not the case, you could do else, or you can just simply say return false. Because if return true does not happen, then return false would. And that's really all there is to that little tiny method. It's just if the length is greater than the starting value, I'd return true. Otherwise, I'd return false. Does that make sense to everybody? Cool. Lastly, part C, I would say the method prop long. I think that's proportion. Proportion of longs, int n. Returns the proportion of long Hailstone sequences with starting values between 1 and n inclusive. Ooh. Consider the following table. It provides data about the Hailstone sequence starting between 1 and 10. So if the user calls the method Hailstone prop long 10, that would return 0.5 since 5 of the 10 Hailstone sequences shown are considered long. How fun. So we kind of have to just do a little proportion of all of the ones that are considered to be long and all the ones that are not. So very simple. I could do something like this. I could say, let's see, int number of long sequences. Let's start that as 0. I'm just going to say while, or actually we could do a for loop here because we're going from 1 to 10, right? So for in I is 1, I is less than or equal to, because it's inclusive of n, I++. Notice if the user passes in 10, we would go from 1 to 10. And what could I do here? I could say, let's see, if, don't we have this cool little method up here to determine if this is a long sequence? So couldn't I say if, look at this, if is long sequence of I, if that's true, how fun is this? Wait, it's all clicking together. Then we could just increase the number of long sequences. Do you see how that statement right there would just go through all of the sequences and say how many of them are long, right? It would say, let's start with 1. Let's check. Is 1 a long sequence? Is 2 a long sequence? Is 3 a long sequence? Because that uses the exact method that we wrote up here, which then uses the method that we wrote up here, right? It all kind of chains together, which I think is really cool. Notice that it doesn't matter if you wrote parts A and B incorrectly. If you understand what they do and use them correctly here, you can still get credit. And this will show up on the AP exam a lot, where if you have to use a previous method in your implementation, it will always say, assume that they work as intended regardless of what you wrote. So you don't get like a double whammy, you don't get double penalized for getting something wrong. So it says for in I is 1, I is less than or equal to n, I++. If is long sequence at I equals true, meaning we're just going to go to the end, then increase. And what do I want to return here? I want to return the proportion of long sequences. So I need to return. How do I do that actual proportion? I believe it's just the number of long sequences divided by the total number of sequences. We do have to make sure we cast to a double as well, so we don't cut off anything. So I'm going to return the number of long sequences divided by the actual number of sequences, which was n, and we want to make sure that we cast one of these, doesn't matter which one, to a double. Okay. The reason why we need to cast to a double again is so that that integer does not get truncated, right? So that it doesn't get truncated to an int if necessary. All right. So I think that should do it. I mean, if anybody has any critiques, then feel free. But I feel like that is exactly what it should be. That you start with no long sequences. We go through all the possible sequences. We say if it's a long sequence, then increase that counter by 1. And then at the very end of all of that, we're going to say, let's just take the number that we actually found and divide it by the total number. And that should return the proportional number of long sequences. Are we happy with that? Cool. Notice this didn't use any loops it did use loops. Didn't use any arrays or array lists. It rather focused on loops and if statements and mods and calculations like that. So I think that the reason why the College Board wanted me to point this problem out to you, it's probably very similar to the one that you're going to get for question 2 on the AP Computer Science A exam, the one that's not on arrays and array lists. So you should definitely be familiar with how to structure loops like this, how to do these if statements, how to do mod calculations, how to do division. Remember to cast to double. I'm sure that's like a point that they'll pick up on the AP exam, and making sure you're returning what the method actually requires you to return. Just very quickly, I want to make sure that I show you the answer key as well as the scoring guide. So keep in mind, in the problem we just went through, this is the canonical solution. It's pretty similar to the one we came up with, right? I use count instead of num terms, but same thing. Notice that this is worth a total of 3 points. You would get plus 1 point if you use loops. Use a loop from a given starting value till the sequence terminates. So literally, if you just type, they said while n is greater than 1. I don't think you'd actually have to worry about it being less than 1. It would never dip to a negative number. So you could just say while n is not equal to 1. Weird. But either way, as long as you put that statement, bam, point. Compute the next value. If you did this if-else structure, another point. And then use this correct formula for the next value to determine even odd. If you did this line and this line, bam, that's 3 points. You get a penalty on if you use an extraneous code that causes side effects. There's no printing. There's no accounting for negatives. You don't have to do that because your precondition is that it's positive, so no worries there. And you also lose a point if you declare local variable or use local variables that were never declared. So if I never said int count is 1, I just started doing count plus plus or something like that, we would lose points. So I think that's a pretty quick one to pick up 3 points. Part B is also worth 3 points. So the way that it's actually done is, this is the actual canonical solution. It actually just returns the result of if hailstone length n is greater than n, because that would be true or false, so that's a fair way to do it as well. If it calls hailstone length, you get a point. Definitely should do that. I mean, there's no reason why you wouldn't do that. Correctly compares it's worth 2 points, sorry. Correctly compares length and starting value to determine return value. So if this statement is correct, done. You lose a penalty if you do extraneous code or declare or use variables that are extraneous. Last but not least, the proportion of a long method. You would get plus 1 point if you call isLongSequence in the context of the loop, which we did. Plus 1 point if you loop 1 to n with no out of bounds errors. Plus 1 point if you calculate the double proportion. Keep in mind, again, we need to make sure we go to a double. I have a feeling that's why it's bolded, because you don't want to have just integer divided by integer. That's not going to be correct. And then plus 1 point if you return the correctly calculated value, and the usual -1 penalties. Here, it's exactly what we do. Pretty much the same thing we did here. I'd say we used the thing of long sequences, but however you want to word it, int count is 0. We go from 1 to n. If it's a long sequence, then we increase the count by 1, and we return the division there of the number that we found, cast it to a double, divided by the total number. Okay? Any question? This is provided for you on Classroom as well, so hopefully you can see that. Any questions, comments, or concerns about how any of those were done at all? then with that being said, I believe we are just about out of time for the day. So, again, in the interim between now and Friday's class, it is expected that you are making headway on your final project and you are studying for the AP exam. If you want to meet with me at all to discuss anything AP exam related, please reach out and do so. I will come up with a plan to somehow touch base with you on Friday before the AP exam, just to make sure that we're all set. I think we actually meet our class. Oh no, it doesn't meet that day because it's the planned day off. I'm pretty sure it's the May 15th, right? So we don't actually have class that day. We meet Thursday, I believe, right before it. So you will have a chance to ask me any last minute questions on Thursday prior to the AP exam. That's probably what I'll dedicate that class to. I'll just be like, 5 minutes of me talking of like, here's what you should have by your side for the AP exam, and then the rest of the time, just if you have any questions, I'll make some sort of plan to see on Friday if I can do something for you. All right. But other than that, thank you so much for your attention and focus today. I will see you on Friday, correct? Because Wednesday we don't have class. Thursday is a white day, so I'll see you Friday, our next blue day together. And I hope you have a fantastic rest of your day. Please let me know if you have questions. I'll see you then. Bye, everyone.
Have a nice day.
See you, Mr.
Bye-bye,
Giorgio.
Mr. Giorgio.
Bye-bye.
See ya.
Later.